Hello friends, welcome back to TechWizLab. This is the third video of statistics basics. In last video, we studied what are the different types of data and what is the population and sample. And then we decided that we'll be talking about the samples in detail in our upcoming video. So, in today's video, we are going to discuss two important things. First, if we have a population data available, how to decide what should be my sample size. And second thing, when we have decided that this many number of samples we need to collect, then what are the different methods available to collect those samples so that we can have a proper idea of the complete population or an actual essence in our sample, so that even though we study of the samples, we are able to get the result with some confidence level and with some known error that this is what is the data is or the answer or the information which we draw from this sample can be said that it's drawn from the entire population. So roll out the intro and we'll connect again. So, welcome back. Today we are going to discuss about the population and sample. Just so it's like population and sample. So, okay. So, suppose we have a very large number of population and we want to collect a sample size for our study. Now, there are two important things that out of this population, what should be my sample size and what should be the methods to calculate the sample. So, coming first to the sample size. So, sample size has a very basic formula that's I'll call sample size uh, is equals to z square into sigma square divided by e square. This is method based on z score method. Now, what these things again we will study them in the detail when the time will come. There is a bit complexity in these formulas, but just try and understand right now. Two things will be studied in our upcoming videos. So let's define what is the meaning of all these things. So the Z here is the Z score value of X confidence interval or level, whatever you call it. Now, sigma is the standard deviation of my population. Now, E is the error of margin considered. Now, what do they mean? Let's so Z score value for any given confidence interval means like uh, at what level of confidence we want to give this statement, whatever we are generating the results based on the sample size. So suppose I say that I want to be confident 95%. So there is a Z score table which readily available on the internet. You guys can go and search. So you'll found that with every percentage values or like the error, you can get the nearby value of that. So its value is 1.96. If you go with the 99%, the value will reach to the 2.2 some number. Okay. So for this, you can always refer and take this value from the internet. Now, sigma is the standard deviation of the population. Now, this will also be having some number. Now, E is the error of margin. Now, even though we know that we are collecting the sample, so suppose we are talking about like what is the average height of all the people who are living in some X city. So, We know that all their heights has been measured into the centimeter. Now I am okay if I am making an error of 2 centimeter, because even though if we go, the general heights are going from 165 to nearby 175 centimeter. Okay. If suppose this is the range of the people, then the 2 centimeter, it's like not more than the 1% of the error of that data. So let's see how to calculate this thing. So I'll be just changing to my page. Yeah. So we mentioned that the sample size should be like z square into sigma square divided by e square. This is my sample size. Now my sample size is equals to 1.96 square, and then whatever is the sigma, suppose if it is the 5 centimeter of the standard deviation, then e is the 2 centimeter. What data which we, while solving this entire thing, we'll be getting the value somewhere near to the 96.05. Now whatever the value comes, we'll round up, and while round we'll be using the ceiling method. Ceiling method means even if the point any value comes higher, we'll make it one number extra. Okay, it's nothing like if it's lesser than zero point 0.5, then we'll be shifting to the 96. So if that sample data which is having the 5 as a standard deviation, and we are ready to take the 2 centimeter of the error, and we should be 95% on confident, then the sample size should come nearby 97 data. Now we have reached to our first answer, that out of this n number of data, the 97 samples we should collect, and we should study that to represent or to drive the final results, or like the average height and the variations in height and something like that, or any kind of study which you are interested in. Now the next point is, these things are okay, but how to take the samples? So for taking the samples, there are four basic methods. So how we call it? Just to remember it, it's very easy. You can remember SSCC. So first S stands for simple random sampling. Second S comes for stratification or stratified sampling. This C comes for clustering based sampling. And this C is convenience sampling. Okay. Now we'll study in detail how they are being selected. Now in simple random sampling, it's like all based on luck. You can select any 97 data points out of available population, and you can call it as a sample. Now this purely depends on like your luck, because maybe the 97 what you have selected are the person who are having the higher height, or maybe who are having the lower height than the average, then definitely your final answer can be biased. So to avoid this thing, what they do in random sampling, they do the hit and trial method. So they do the many iterations, and whenever their answers comes to a stable part, they fix this variable at their part. Now, stratific sampling, how it's it? Based on some characteristics, they divide the entire large size of population into some blocks, and then select the one or fixed number of samples from each and every block which represents that block, and do the calculations based on that. Now, coming to the clustering sample. Now, clustering sample, again, they are doing the same thing. They are making some natural clusters of entire population and select few clusters, but the entire population data available in that clusters are being selected. Now there is a difference between this stratific sampling and the clustering sampling. In clustering sampling, you are selecting the entire cluster, whereas in stratific sampling, what we are doing, we are dividing it into some different zones, and then selecting the fixed number of people or the data set from that part and taking that fixed number from each and every group what we have created based on whatever the criteria we had. Now, last is the convenience sampling. Convenience sampling is the easiest method. It's like whatever the data is easily available to you, you just select that and you can run your study on that. But the point is like this is highly biased part. Now, suppose like in simple random sampling, we have collected the higher number of data for the population, and then now we are doing so. We have a chance of doing the hit and trial. But if I give you an example of convenience sampling, it's similar like that. I wanted to gather some political parties review. So I went to one specific place and some people gathered there looking at the mic and the camera and the new setup. Now maybe that the people who lives in that area, they are more biased toward one of the political party. So my answers will be totally biased in that section, right? So that's the data set which was easily available. Now in this case, I'm not allowed to take my setup again and again in each and every area to gather the more samples or like to doing the hit and trial method. So that's why the convenience sampling is the easiest and the cheapest method, but this will always be a highly biased method. So these all are the methods of doing the sampling. I hope you liked or you enjoyed this method. We try to make it as simple as possible for everybody. If you have any questions related to that, how to select your sample size and what should be the methods, you can definitely connect to us. You can put your comments and any other suggestions are most welcome. I hope you liked it. Thank you so much. See you next time.